When astronomers and physicists talk about the most dangerous things in space, they usually start with the usual suspects. They talk about dark matter, an invisible, massive force holding entire galaxies together, surrounding us in the dark, yet totally undetectable to human eyes. Or they talk about antimatter, a substance so violently unstable that a single gram touching normal matter would trigger an explosion equal to a nuclear warhead. These forces are terrifying, but they follow the fundamental laws of nature. They exist, they interact, and they stop. Antimatter destroys itself when it hits normal matter. Dark matter passes right through us without leaving a trace. They do not infect, they do not spread. To find the absolute most dangerous substance predicted by modern physics, you have to look past dark matter, past antimatter, to a microscopic, glowing subatomic sludge. If a single drop of this sludge ever touched a planet, that world would not explode like it hit antimatter. It would not crumble into pieces, it would be converted. Every atom it touches is forced to abandon its shape, corrupted at the subatomic level, and merged into a dense, lifeless liquid. Once that chain reaction begins, it never stops until the entire celestial body is turned into a uniform lump of cosmic slush. This isn't sci-fi horror. It is a mathematically sound prediction born from quantum mechanics. It is called strange matter, and it makes every other cosmic threat look completely harmless. To understand how a single particle could infect an entire planet, you have to look inside the fundamental building blocks of reality. Look at your hand, your screen, or the air around you. Everything you see is made of atoms. Inside those atoms, locked in the nucleus, are protons and neutrons, and for decades, science taught us that these were the smallest pieces of the puzzle. They aren't. Inside every proton and neutron are even smaller fundamental particles called quarks. In our everyday universe, nature only uses two types of quarks to build everything. Up quarks and down quarks. Two up quarks and one down quark give you a proton. Two down quarks and one up quark give you a neutron. They are locked together by the strong nuclear force, bound so tightly that they create the rigid, stable matter that builds planets, stars, and living beings. For billions of years, this arrangement has worked. It feels permanent. It isn't. Deep in the cold vacuum of space, inside the crushed heart of a dying neutron star, gravity reaches a level of violence that defies imagination. The pressure is so immense that individual atoms cannot survive. Protons and neutrons get squeezed together until their outer shells dissolve, melting into a chaotic, liquid soup of raw up and down quarks. And under that unthinkable pressure, a quantum glitch occurs. Half of those up and down quarks spontaneously transform into a third, heavier flavor of particle, the strange quark. When strange quarks mix with up and down quarks in equal measure, they create a new form of subatomic arrangement called a strangelet, and unlike normal matter, which requires vast amounts of energy to hold its structure together, strange matter achieves something terrifying. It reaches the ultimate state of thermodynamic stability. It is lower in energy, tighter in structure, and more permanent than any atom in the periodic table. One of the most fundamental rules in all of chemistry and physics is simple. Everything in the universe seeks the lowest possible energy state. Fire burns to release energy. Water flows downhill to reach baseline potential. Atoms bond, react, and decay for one single reason. They are desperately trying to become stable. In our everyday world, standard atoms are stable enough, but strange matter breaks the curve. It sits at a when strange quarks mix with up and down quarks in equal measure, they create a new form of subatomic arrangement because nature naturally defaults and unlike normal matter, which requires doesn't just passively resist strange matter. The moment they meet, normal matter wants to fall into that lower energy state. It naturally surrenders its structure to become strange, making it the absolute most stable and most infectious form of matter in existence. Imagine a single strangelet, a microscopic droplet of strange matter forged millions of years ago in a neutron star collision, drifting silently through deep space. It travels for eons, untouched, until its path intersects with Earth. The impact wouldn't look like an asteroid strike. There would be no blinding light, no crater, no shockwave tearing through the atmosphere. The second that microscopic droplet touches the ocean or the ground, the infection protocol begins. Because strange matter exists at a lower energy level than normal matter, normal atoms are fundamentally unstable by comparison. The moment a normal atom touches a strangelet, its nucleus is immediately overpowered, its protons and neutrons melt, its up and down quarks are sucked into the liquid, rearranged, and forcibly converted into strange quarks. That newly converted atom becomes strange matter itself, and now it infects the atoms next to it. If you were standing near the impact point when a strangelet made contact, the experience wouldn't be like catching fire or being struck by lightning. The instant the infection touched your skin, your body's atomic structure would begin disintegrating at the fundamental level. The carbon, oxygen, and hydrogen atoms holding your cells together would immediately melt as their protons and neutrons dissolved. You wouldn't bleed, and you wouldn't burn. You would simply watch your hand, and then your arm, lose its physical form, converting instantly into a dense, silent stream of subatomic liquid. Within seconds, your entire physical existence would be rewritten into the exact same uniform sludge, joining the chain reaction as it burrows straight toward the center of the Earth. A subatomic domino effect spreads outward in all directions. The ocean doesn't boil, it dissolves. The Earth crust doesn't shatter, it turns into a dense, heavy, glowing sludge that sinks toward the center of the world. As a reaction consumes the mantle and core, the tremendous gravitational pull of this hyperdense liquid takes over. Within minutes, our 12,000 kilometer wide planet collapses in on itself, shrinking down into a silent, lifeless lump of sludge no larger than a city block, floating forever in orbit around the sun. We used to think the universe would end in fire or ice, but according to the laws of quark physics, reality might just end in a quiet, unstoppable rewrite.